Good morning everyone, myself Amandeep Kaur from GPCG Patiala, and today I am here to represent a topic of relational database management system, which is normalization. The contents that we are going to study in today's lecture are the purpose of normalization, what is data redundancy, and what are the update anomalies that occur when you normalize any relation. And the next will be, why do we choose normalization? Why do we normalize the tables which are having data in them? What are functional dependencies? The full process of normalization, and later on we will study all the forms of normalization, that is first normal form, second, third, and then comes the BCNF, which is Boyce code normal form. It is a special normal form which is included in normalization, and then fourth and fifth, and the last topic will be denormalization. So let's start with today's topic. The normalization, after the designing of any table, then you need to ensure the data which is stored in the database is accurate and consistent along with time. Whenever you are making any kind of changes to the database, it must ensure that the consistency of your database is remained. So in relational database theory, normalization is the process of restructuring the logical data model of a database to eliminate redundancy, which stands for duplicacy of data, organize data efficiently and reduce the repeating data, and to reduce the potential for anomalies during data operations. So why do we use normalization? The basic purpose of the normalization is we have to restructure the logical data model, whatever we are using to construct the database, in order to eliminate the duplicacy of your data. That means there should be no duplicate values in your database which you are constructing, and moreover the data which is being stored in your database should be efficiently organized, and along with that you need to reduce the repeating data. And to reduce the repeating data, you will have to take care of the anomalies whenever you are doing any kind of operations on your database. For example, if you are inserting some sort of information or deleting the information, or you may modify the information which is stored in your database. So all this is done using normalization. Data normalization also may improve data consistency and simplify future extension of the logical data model. By the term consistency, we are referring that the information which is stored in your database should not contradict to each other. For example, if we are storing duplicate values, it will result into inconsistency of the information which is stored in your database. The formal classification used for describing a relational database level of normalization are called normal forms. Whenever we normalize any information which is stored in the database, we will be using various normal forms. There are 5 normal forms. By reaching each level, you will refine your data structure, or you will refine your database and the information which is stored in your database. The normal forms are abbreviated as NF. You will say first NF, second NF, and third NF. Now, what is the purpose of normalization? After using normalization, what will be reflected in your table? Normalization is basically a technique for producing a set of relations with desirable properties given the data requirements of an enterprise. The process of normalization is a formal method that identifies relations based on their primary or candidate keys and the functional dependencies among their attributes. Whenever you are using normalization, you will ensure that the information in your database is consistent, accurate, and it is unique as well. So by involving all the forms of normalization in your table, you can eliminate the redundancy, duplicate values of your database. Why do we use normalization? A non-normalized database can suffer from data anomalies. There are various types of anomalies. They are known as updation anomalies, insertion anomalies, and deletion anomalies. If your table is having duplicate values, the values which are stored in your database will be definitely inconsistent. A non-normalized database may store data representing a particular referent in multiple locations. For example, a record of a student may be stored at more than one locations, which will result into inconsistency. For example, if the address of the student is being changed and the information is residing at two different places, there is a possibility that you may change the address of student at one place but not at the other place. So an update to such data in some but not all of those locations result in an update anomaly. So this will be known as update anomaly, that because you are doing changes to the record of the student at one place, but you are not ensuring that the information, the change in the information is being reflected at all the places. It will result into update anomaly, which will further yield inconsistent data. Just because of this update anomaly, your database will be storing inconsistent data, which means that the data which is stored in your database will be incorrect, because the address of the student will be at the different places, the address will be different. A normalized database prevents such an anomaly by storing such data in only one location by using the primary keys. But if you are using normalization in your database, in that case, because the information is stored in only one location, and by using normalization, the information which is stored in your database will be stored only once, so the inconsistency of the data will not occur at all. The next thing is, a non-normalized database may have inappropriate dependencies. For example, one attribute of your database will be depending on some other attributes. Such dependencies should not occur in your database. It means the relationship between data with no functional dependencies. Adding data to such a database may require first adding unrelated dependency. A normalized database prevents such insertion anomalies by ensuring that database relations mirror minor functional dependencies. Whenever you are using a database which is not normalized at all, such a database may have dependencies which are inappropriate. For example, some of the attributes of your database are dependent on another attributes, and in such a relation you may have to enter some irrelevant information in your database, which will further result in insertion anomalies, which is a disadvantage of the non-normalized data. Similarly, such dependencies in non-normalized databases can hinder deletion. They may affect the deletion function of your database as well. That is, deleting data from such databases may require deleting data from the inappropriate dependency. In such non-normalized databases, sometimes you want to delete some information, but along with that information which is not required at all, some of your important information can also be deleted. So a normalized database prevents such deletion anomalies by ensuring that all the records are uniquely identifiable and contain no extraneous information. So these are the disadvantages that occur if you do not normalize the information which is stored in your databases. You may have to face the anomalies like update anomalies, insertion anomalies, and deletion anomalies. To prevent all these things, you may have to normalize your information. So whenever you are performing normalization, you may have to attach a primary key to your table, and apart from that you may have to make sure that all the attributes are atomic of your database, because all the attributes must be having one and only one value. There is an example of update anomaly which occurs whenever you want to update the information of any database entity. To insert there is a table which is known as staff branch. There are number of attributes in that table: staff number, staff name, position on which that the person is working, salary, branch number and branch address. To insert a new staff with branch number B007 into the staff branch relation, it is the update anomaly, and to delete a tuple that represents the last member of staff located at a branch B007 and to change the address of branch B003. You will have to do all these changes at number of places, not only one place, but if you are using a normalized database, you will have to make the changes at one single place only. So these are the update anomalies that occur in your database if you are not using normalized databases. There is another example of update anomaly. We are having two tables here, one is staff and other is branch. So what is the difference between a non-normalized database and a normalized databases? Let's discuss this topic. The normalized databases have a design that reflects the true dependencies between tracked quantities that are known as attributes, which allow you quick updates to data with little risk of introducing inconsistencies. Because the information in the normalized tables is stored only once, so in that case the risk of the inconsistencies, which is inaccurate data, is very low, because if you are making changes to the database, you will have to make the changes at one place only. So by doing this, you are eliminating the duplicacy, but as well as the inconsistency of your data as well. Second is, instead of attempting to lump all information into one table, data is spread out logically into many tables. We have whenever you have to store huge information, instead of having one single table, you need to spread all your information into various tables. For example, if you have to store the information of employee as well as their projects they are being handled, so instead of making taking all the information into one single table, you should spread the information into many tables. You should have two tables. One will be storing the information of the employee and other will be storing the information about the projects that are being handled by all the employees. So this is done in normalized tables. Normalizing the data is decomposing a single relation into a set of smaller relations which satisfy the constraints of the original relation. By normalizing as well, what we are doing is you will decompose a single table, which is a relation, into different smaller relations which will be satisfying the constraints of the original relation. What are the constraints? Basically, constraints are some sort of rules and regulations which are defined by the original relations. All those constraints will be implemented in all the tables which are further divided from the which are further derived from the original relation, which will be the base relation. Moreover, in normalized databases, redundancy can be solved by decomposing the tables. Redundancy refers to duplicacy of data. Whenever you are decomposing the tables, by doing this, the duplicacy of the data can also be eliminated to a great extent. However, certain new problems are caused by decomposition, because you will have to repeat some sort of fields if you are decomposing one relation. Normalization helps us to make a conscious decision to avoid redundancy, keeping the pros and cons in mind. By using normalization, you can eliminate the redundancy, but you should know what are the benefits and what are the loss of doing this decomposition and redundancy as well. One can only describe a database as having a normal form if the relationship between quantities have been rigorously defined. The relationship between attributes and and between the relation should be defined properly. How two relations are being related to each other and on what basis, it should be clearly defined by the database. Moreover, it is possible to use set theory to express this knowledge once a problem domain has been fully understood. But most database designers model the relationship in terms of an idealized schema. Schema is, what is schema? Schema is basically the overall design of your database. The mathematical support came back into play in proofs regarding the process of transforming from one form to another. Whenever we are talking about relational database management system, you may relate the RDBMS to set theory, which is used in the mathematics. There are number of sets. The way you join the sets, the similar method is being applied into databases also. You may relate all complete relation with another relation, and moreover you may have one or two attributes which are being related to each other as well. So, this transformation of conceptual model to computer representation format is known as normalization. Whenever you are using normalization, you will be transforming the information which is designed into the ER model to the relational database management system, which is in the form of tables. This transformation is known as normalization. There is a basic term which is known as functional dependencies, as we talked earlier. The functional dependency is between the attributes of a relation. There is the functional dependencies between attributes, how one attribute is dependent on the another attribute. These are known as functional dependencies. There are various functional dependencies. It describes the relationship between the attributes in a relation. For example, if A and B, two attributes of relation R, and B is functionally dependent upon A, where those are denoted by A and B, if each value of A is associated with exactly one value of B, A and B may each consist of one or more attributes. This is the functional dependencies between two attributes of a relation. We are having a relation R and we are having two attributes A and B. For example, you can take employee name and employee ID and say the employee name is dependent upon employee ID. So, by that all the values of employee name will be dependent on employee ID of relation employee. So, this is the functional dependency between two relations, two attributes. The determinant, which is the name of your attribute, it refers to the attribute or group of attributes on the left hand side of the arrow of a functional dependency. There may be trivial functional dependencies as well. It means that the right hand side is a subset of the left hand side. For example, staff number and S name are dependent upon S name, and staff number and S name are dependent on staff number. They do not provide any additional information about possible integrity constraints on the values held by these attributes. What are the integrity constraints? They define the accuracy of your database, that they refer that the information which is stored in your database is accurate to possible extent. We are normally more interested in non-trivial dependencies because they represent integrity constraints for the relation. The overall goal of the normalization is to provide accurate data to the user and inconsistent data, which is provided by non-trivial dependencies. Main characteristics of functional dependencies in normalizations are: they have a one-to-one relationship between attributes on the left hand side and right hand side of a dependency, because generally for a functional dependencies we must have two attributes. One of them is dependent on another attribute, and it holds for all time and they are non-trivial. These are the general characteristics of a functional dependency that we use in normalization. The functional dependency is a property of the meaning or semantics of the attributes in a relation. What are semantics? Basically, they are some sort of geometrical expressions which need to be satisfied by the information which are being stored in your database. When a functional dependency is present, the dependency is specified as a constraint between the attributes. So this is noticeable as the functional dependency is treated as a constraint between the attributes. If one attribute is functionally dependent upon another attribute, it will be treated as a constraint, some sort of primary key or candidate key. It is noticeable. An important integrity constraint to consider first is the identification of candidate keys, one of which is selected to be the primary key for the relation using functional dependency. Whenever you are normalizing your databases, you will be asked to choose the candidate keys. What are the candidate keys basically? These are the attributes of your table which can uniquely identify the information which is stored in your database. Now there may be number of candidate keys which can uniquely identify the information. For example, the name of the student can identify, or the roll number of the student can identify, the student ID can identify the information. But from all these candidate keys, we have to choose only one key which will be considered as the primary key for the table. Now what are the inference rules? Inference rules are basically a set of all functional dependencies that are implied by a given set of functional dependencies. X is called closure of X, written X plus. A set of inference rule is needed to compute X plus from X. There are axioms like reflexivity, augmentation, transitivity, and self-determination, decomposition, union, and composition. All these are coming from the set theory of the mathematics. Next is the minimal set of functional dependencies. A set of functional dependencies X is minimal if it satisfies the following condition, which is given as every dependency in X has a single attribute on its right hand side. And moreover, we cannot replace any dependency where A depends upon B in X. X stands for a relation which is being used. A and B are the attributes of that particular relation. With the dependency C belongs to B, where C is a proper subset of A and still have a set of dependencies that is equivalent to X. And we cannot remove any dependency from X and still have a set of dependencies that is equivalent to X. So these are sets of functional dependency that a table may be having. There is another example of minimal sets of functional dependencies. A set of functional dependencies for the staff branch relation, it is the table name, satisfy the three conditions for producing a minimal set, where staff number belongs to staff name and staff number again belongs to position. All these staff names, position, salary, branch number, branch address, all these things are dependent upon staff number, whereas the branch address is dependent upon branch number, salary are dependent upon position and branch number, and position and B address. So these are the minimal sets of functional dependencies which are present in a staff branch relation. Next is the process of normalization. If you are normalizing a particular database, how will you do that? What is the process? What are the steps to be which should be followed to normalize a database? Basically, the normalization is often executed as a series of steps. Each step corresponds to a specific normal form that has known properties. While doing normalization, it will be executed as a series of steps because there are a number of forms of normalization which should be included in your database to fully normalize your data. As normalization proceeds, the relations become progressively more restricted in format and also less vulnerable to update anomalies. As you proceed to normalization, you will notice that the redundant data from your database will be eliminated and it will be formatted properly, and moreover, your database will be free from the update anomalies. Thus, it will contain consistent information. That means it will be having accurate information. For the relational data model, it is important to recognize that it is only first normal form that is critical in creating relations. All the subsequent normal forms are optional. Whenever you are doing normalization, you have to make sure that you implement first normal form very carefully. After that, all the normal forms are optional. You may skip one of them. Let's study the first normal form, what it says. The first normal form requires that the table be made of a primary key and number of atomic fields, and second and third deal with the relationship of non-key fields to the primary key. In the very first normal form of your normalization, what you have to do is you will have to identify a primary key for your database, a unique field which will be identifying the information of your database uniquely. All the rows in your database uniquely, they will be identified uniquely by using the primary key. Moreover, you will have to make sure that all the attributes are having atomic values. That means one row and one column should be having one and only one value at a time. And the second and third normal forms, they are dealing with the relationship of non-key attributes to the primary key. What the non-key what type of relation the non-key fields are having with the primary key. All this is done in the later forms. These have been summarized as requiring that all non-key fields be dependent on the key, the whole key, and nothing but the key. It says that all the non-key fields which are not uniquely identified, they should be dependent upon the primary key only. In practice, most applications in 3NF, which is third normal form, are fully normalized, because up to this extent the table is normalized, all the tables are having atomic values, all the redundant values are removed from your table. However, research has identified potential update anomalies in 3NF databases. But the research says another thing, that even after reaching third NF, the database may be having update anomalies, which is known as modification anomaly, which leads to inconsistency of your data stored in your database. Next form is a special normal form, which is known as BCNF, which stands for Boyce Code Normal Form, is the further refinement of 3NF that attempts to eliminate such anomalies. As the research says that even after reaching third normal form, the databases may be having update anomalies, but by implementing Boyce Code Normal Form in your database, you may eliminate the anomalies which are known as update anomalies. Next form, which are fourth and fifth normal forms, they deal specifically with the representation of many to many and one to many relationships. The sixth normal form only applies to temporal databases. Now let's discuss in detail what is first normal form. Unnormalized form will be a table that contains one or more repeating groups. The repeating group is recognized, which is property number, property address, rent start, rent finish, rent owner number, and a number. All these are the repeating group of fields. That means we are having repeated values in all these fields. You can notice from the table as well, all these fields are having repeated values. What is the definition of first normal form? How will you define it? First normal form is a relation in which the intersection of each row and each column contains one and only one value. There are two approaches to remove repeating groups from a normalized table. What you have to do in first normal form is, first you have to identify the primary key for your table, the unique field which can identify all the information in your database, and moreover you will have to remove the repeated group of fields, the information which is being repeated in your database, to another table. First step will be it will remove the repeating groups by entering appropriate data in the empty columns of rows containing the repeating data. And secondly, it will remove the repeating group by placing the repeating data along with the copy of original key attribute, which is the primary key, in a separate relation, and a primary key is identified for the new relation. So, these are the steps that you will be performing in your first normal form. With the first approach, we remove the